Hi, welcome to a product review by Watt Hour. In this video we are going to have a look at this. This module is sold as dual power supply back boost converter, which means that it has input and then at the output we have ground, positive and negative. So this positive is positive with respect to ground, and this is negative with respect to ground, which means this becomes positive and this becomes negative. And it's supposed to give you from ground and positive and negative to power. For example, if it was 12, you get ground and 12, and from ground the negative 12. But this is not doing that. I just tested it. If you want to just use it as a back boost converter, which means you give it 12 volts, it can give you also 30 volts, and you can go to towards 0 up to 5 volts, 3 volts, all the other voltages. You can get also the lower and higher voltage. So this will not give you proper dual power supply. That's why I'm rejecting it, because for example, if you want to get 20 volts 1 ampere, you cannot get minus 20 volts 1 ampere, because it's not balanced, it's not good. So this should not be like this. Let's have a look at the thermal image. 76 degrees Celsius, that chip in here exactly where my finger is. And here on the diagram, as you can see, we have input, which is positive and negative, and you can connect your power supply, and then it has output. At the output, it's supposed to have a positive and negative with the ground. So from ground to positive will be positive, from ground to negative will be negative, and that makes it dual power supply. But this module is not dual power supply, it's just back boost converter. I bought this from AliExpress, from this store, electronic station store. I paid around $8.83, and this is for 60 business days. So you will receive it in 90 days, but if you pay a little more, so around $2.20, you will get it in 30 business days, which is around 30 to 40 days, but still that's good. Like most other stores, they do not put the model number. Even though on the back we have the model number. There the model, they mentioned it, input voltage 3.6 to 30 volts. So that's input, I'm going to test it, and output plus minus 3 to 30 volts. So output is 30 volts maximum, input is also 30 volts. And here is the data sheet for this XL6019 from XL Semiconductor. This is a 60 volts up to 60 volts 5 ampere switching current and back boost converter, or DC to DC converter, but this is not a dual power, and you will not find any circuitry or any application example that shows that this is a dual power supply. But this could be used as a dual power supply with other converter, with other components, not like itself. But the module that we have has only this chip and nothing else. This is just a simple diode and capacitors. No other semiconductor is here to facilitate the dual power supply feature. If you want to charge a battery with this, we cannot use this because this does not have constant current, which means we cannot control the amount of current, and if you let higher current or voltage reaches the battery will be damaged. So for that, we need to have constant current, or CC, which this one does not have. So let's measure the output voltage, and we will see what is the minimum and maximum voltage. As you can see, input voltage is now 12 volts. Let's check what we can get with maximum voltage. I'm just rotating it clockwise. You will see the voltage in here. So that's the maximum. The maximum voltage that you're getting is 31 volts from ground and positive. And this is now from ground and negative. I've connected it to the negative pen. So this is now this is the voltage. Now this is from ground and negative. So that is the voltage that you're reading. This is negative voltage. And if you measure the voltage between, if you measure between the negative and positive, here we are getting 62 volts. So these two voltages have been added together, so you get double the voltage. And as you can see, the idle current is 100 milliampere. Of course, some portion of it is due to my electronic load, like few milliampere, but this is 100 milliampere. The consumption of this is called quiescent current when there is no load. Now I'm decreasing the input voltage. You will read it in here. Let's go. Let's see how stable it is. So the output. So many people ask, if I change the input voltage, what happens? So here is what happens. So I'm going low and high, 20 volts, it's 31, and if I go lower, still it's 31. So that's the meaning of a regulator. So it has to regulate the output regardless of the input. And now I'm reducing the input voltage. Still we are getting the input current increased. Pay attention. So input, they say 33.6. I have to test it with different current to see if it even works below this. But let me increase it back to 30 volts. As you can see, the output is stable. So 25, 26. So input is 30 volts, still output is 31, and it is holding. So if I just go down, this is interesting. When I reduce the voltage, the current increases. So let's disconnect this without any load. Just pay attention. I'm changing the input voltage. So if I reduce it, this standby current increases because this is working hard to make it 30 volts. So output is 30 volts. So now 44 milliampere. So 50 milliampere almost. Yes, for 50 milliampere at 3.7 or 3.6 volts. Keep that in mind. But now if I go higher, this is reduced. So perhaps that's the amount of power it needs. Even 6 milliampere. Whoa, that's very little. Now let's test the boost and see what is the minimum input voltage here. I've connected it to the ground, the middle pin and the positive. Output is now about 12 volts and input is 8 volts. I'm reducing the input voltage to see at what voltage it can keep it. I'm also turning it with 1 ampere. As you can see, again it jumped to 1 volt extra, it added. So now I'm reducing this input voltage. So pay attention to see when this is dropping. As you can see, when I reduce the voltage, the output current is increasing. That's okay, because we are getting specific wattage. So input has increased and suddenly the voltage dropped. It's supposed to be 30, so it doesn't work now. I'm increasing it. Increasing 6 volts will not give you 6.7, 7. So now let's reduce it. So 5 volts will not give you proper voltage. 12 volts, so dropped. Let's increase it back. So this is without, if I turn the load off, we will see the voltage will go back. But if I turn it on, the voltage is dropping. So I'm increasing the input voltage and say, this has to be stable. This has to be stable. So as I increase the input voltage, you see some millivolts, 100 millivolts will be added slowly. Now it's stable. So 6 volts will not give you, if I turn it off, you will see that it will not give you. So 6 volts, so 6.5 volts, 6.4 volts. So minimum voltage is 6.4, because if I reduce it, the voltage is dropped. So 6.4 will give you proper output. 6.5. Now again the voltage is here. So 6.5, if I turn it on, it will keep it, but if I go up or down, then it cannot do it. As you can see, 6.5 will not give me 12 volts. 6.5 will not give 12 volts. So I have to go higher, even higher. So 7 volts. So minimum voltage is 7 volts. So let's have a look at the quiescent current or standby current. I'm disconnecting my load. So now the load is disconnected. As you can see, it shows 10 milliampere. That's interesting. And once we read the output voltage, it increases to 100 milliampere. This is my setup. You will see the input voltage, input current, and you will see the output voltage and current in here. Now let's set the output current to 0.5. So Now with 0.5 we are getting 1.8 ampere at the input. Very cool, that's nice. So that's 0.6. The voltage has increased, that's strange. I set it to 30 volts, so it has jumped to 31. Let's turn off the load. Again, the voltage is stable, but when I turn on the load, the voltage increases. With 0.6, with 0.6 ampere at the output, 30 volts, input is 12 volts, 2.128 ampere. Now let me increase it to 0.7. Output is 30 volts, so this is 31 and 0.7, 700 milliampere. Input is now 2.46 ampere at 12 volts. Let me show you the thermal image. 86 degrees Celsius, 85. This is a thermal camera. The link for the camera is below the video in the description. It's not sustainable as this heats up, it is being reduced. So let's reduce it back to 0.6. So the voltage is now slowly recovering. The chip was hot, very hot. So it seems it came back. Now you have to understand that this is now the room temperature, and if the room gets hot, this will also get hotter. And now output is 24 volts. I've connected it to the positive and ground. Let's go 300 milliampere. So we are getting 300 milliampere, 24 volts from 12 volts. And let's increase it 400, 500, and then 600. Now because I've reduced the voltage, it is possible that I might get higher current. Let's go 0.7 and see if the voltage drops in few seconds. It's getting hot, but still, let's see. Let's have a look at the thermal image. 76 degrees Celsius. That chip in here exactly where my finger is. So 76 degrees Celsius, it's not changing. Let's go 0.8. The voltage has increased a little. It was 24 volts, now 24.7 or 8. If this voltage drops slowly, it means thermal shutdown is protecting it, so I can see it is being reduced. So now decreasing because it's getting hot perhaps. Let me show you the thermal image. 90 degrees Celsius. So very hot. The voltage has dropped, so let's reduce it to 0.7 and pay attention that this will recover as this cools down slowly. Yes, the voltage has recovered. So we came to conclusion that without a heatsink, we can get 0.7 at 24 volts output. So input is 12 volts, input 12 volts, 1.88 ampere, output is 0.7 volts, 24 volts, and here is the efficiency. Now output is 18 volts, input 12 volts. Let's go with 0.7 ampere. So the voltage is increasing every time I turn on the load. As you can see here, 0.5 volts increase in the output voltage. With this 0.7 and 18 volts output, input is 12 volts, 1.44 ampere. Now let's increase the current to 0.8 and see, because we have reduced the voltage. Now let's see. 0.8 ampere. Input current is 1.617 at 12 volts. If the voltage is dropped, then it means thermal shutdown is trying to protect it as this heats up. It is heating up, but let's see. The voltage is being reduced. I can see it slowly. Stop. Now I have this heatsink. I bought it from AliExpress. It has this adhesive sheet. Let's remove it and put it on this so we can get some cooling here. And now let's turn it on after putting the heatsink. So we have this heatsink now. Let's see if that helps. And let me show you the thermal image. As you can see, it shows 54 degrees. So big help. Simple heatsink. Here, I bought these. They are amazing. So make sure to get these. Now let me increase the current to 0.9 and see if it can handle it. So now we are at 0.9, 16.8 watts. Very cool yet. After a few seconds or minute, here is the thermal image. 67 degrees Celsius. Let's go 1 ampere. So with 12 volts, 1.833 ampere at the input, output is 900 milliampere, 18.6. Now let me increase the current to 1 ampere, and now it's 1 ampere, 18.7, so multiply it, 18.7 watt. Input current is 2.044 ampere at 12 volts. Let's see. This is cool. 75 degrees Celsius. That's very normal for this. Now input is 12 volts, output is 5 volts. Let's go with 1 amp. Now it's back converter or step down converter, so we are getting from 12 volts, we are getting 5 volts. Now let me increase the current and see if we can get more current. 1.1, so 1.2, 1.3, 1.4, 1.5, still holding. That's with the heatsink. Wow, that's very cool. Let's go higher. Push it. 1.7. 1.8, 1.9. So we have pushed it even to 2 ampere. So back converter is working very well. Absolutely, it's good. I think I'm going to go more. The chip is rated for 5 ampere, but the circuitry might not be able to handle it, but let's see. So 2.2, 2.3, so they say it is 20 watts, so now it's 12 watts, but it doesn't mean it can handle it. 2.5 ampere. This is now getting hot, but let's see. Very cool, unbelievable. So 2.6, 2.7. Pay attention to the current. 2.7 is 1.6 ampere at the input. .8, getting hot. 2.9, more hot. Whoa, that's getting hot, so it means, let me show you the thermal image. No, that's 68 degrees. So 68 degrees Celsius. But we will see the voltage will drop slowly, as you can see. So it is heating up. So the voltage has slowly dropped. When I reduce the voltage, as you can see, the output increase. So with the heatsink, 2.7 ampere, 5 volts, input is 12 volts, 1.58 ampere. Now input is 2.7 ampere, 3.2 volts. Input current is 1 ampere, 1.06 at 12 volts. And let me show you the thermal image. (63–64 degrees Celsius). It has heat up a little, but still holding. I have connected it between the positive and negative, so the voltage is doubled. This is 12 volts between ground and positive, but because I've connected to the positive and negative, we are getting 24 volts. And let's go with 1 ampere. As you can see, it cannot supply 1 ampere. Now input is 30 volts, output is 3.3 volts. Let's go with 2.7 ampere. And input current is 416 milliampere at 30 volts. Output is 2.7 at 3.27. As you can see, this is dropping, or 8.85 watts. So keep that in mind, and if you don't put heatsink, it will not work. Now input is 30 volts, output is 5 volts. Let's go with 2.7 if it can handle it. Input current is 607 milliampere at 30 volts. So with 2.7 and at output 13.5 watts. Now I've connected the output to the positive and negative. So this is full positive and negative, and output is 60 volts, as you can see. I'm sure this cannot handle 0.6, but let me turn it on. As you can see, input current has increased, and slowly this is the voltage is decreasing because thermal shutdown is turning it off. So I reduce the current to 0.5, the voltage is recovering. Let's go 0.4. Because if that was 0.6 with a single power, now with the dual power it should be 0.3. Let's see. So even with 0.3 we are not getting 60 volts fully, because if I turn it off you will see that this is 60 volts. So we can get 300. The voltage has dropped. Not trustworthy if you want to use it with the dual power. Now I've connected it just between negative and ground. Output is now, that's minus 11. I've reversed the polarity so we can read it. So we have here minus 11 between ground and 0.5 ampere. Let's see. So it doesn't work. You cannot get any power from negative and ground. So for conclusion, I can say that this chip is not designed to be dual power supply or a converter. It's just back boost converter, and that's it. So the negative portion of this is very limited. I've just done the test, so not worth buying it or trusting this. But I did the review. In this video we are going to do the review of this 50 volts 20 ampere Wurji WZ5020L back converter, 20 ampere or 1 kilowatt. We are going to test it at different voltages, up to 55 volts at the input and up to 20 ampere. It needs more current, so the constant current is turned on, but we are not worried. Input current 10.8.